Hi, my name is Irsyaduddin Najwa bin Nazaruddin. I am a first year student from School of Physics, majoring in Applied Physics. I am as the scriptwriter for this video presentation.
Hello guys, my name is Mohamad Fareez bin Shafie. I'm a third year student from School of Educational Studies. I'm taking course Science with Education and I am the video editor for this project.
Assalamualaikum and hi, my name is Nik Syaza Sabihah binti Nik Ismail. I'm a third year student from Educational Studies. I'm taking Mathematics as my major and Chemistry as my minor. So today I will be your presenter about this topic. Enjoy! Okay, from this video we can see vehicle and automotive have been one of the most essential parts of our life. So in this video, I am going to explain about the most important application of solenoid in automotive. But before we go more deeper into the explanation, you may have wondered what is solenoid is. So let me explain to you what is solenoid. What is solenoid? So in a simple word, a solenoid is a coil insulated or in the melt wire wound on a rod-shaped form, made of from iron, solid steel, and powder iron used as an electromagnet. When the current flows into the coil, most of the resulting magnetic flux exists within the core material. The function of the solenoid itself have different according to the different type of solenoid. So here we have 5 types of solenoid. We have AC laminated solenoid, we have DCC solenoid, we have DCB frame solenoid, we have linear solenoid, and last but not least we have rotary solenoid. In this video, we are focusing on the usage of a linear solenoid in automotive, which is known as starter solenoid. Solenoid basically converts electrical energy to mechanical energy, will hence causing a movement or motion. A linear solenoid is an electromagnetic device that converts electrical energy into a mechanical pushing or pulling force or motion, or generally it produces a linear motion. As in all electromagnets, a magnetic field is created when an electric current passes through the wire. Electromagnets have an advantage over permanent magnets in that they can be switched on and off by the application or removal of the electric current, which is what makes them useful as switch and valve and allow them to entirely automate. Let's get deeper into explanation. You must be very excited to learn starter solenoid. So first, we have starter solenoid that actuated to engage the starter motor of the internal combustion engine. It is used to move the starter pinion into engagement with the rear gear of the engine. It is normally attached directly to the starter motor which it controls. Okay, now please be focused. You might miss the step. There are 6 steps there. But the first one is the starter solenoid will receive a large electric current from the car battery, and a small electric current from the ignition switch. We can call this as a solenoid energized. It has a coil with free movable plunger or an iron rod with a spring inside it. Now look, can you see the coil surrounding the metal coil? So the second step is when the ignition is turned on, a small electric current is sent through the starter relay and the solenoid is energized. The starter relay will allow a large current to flow when you turn the ignition key or press the start button in your car. The ignition switch cannot handle the large current required by the starter motor. This causes the plunger to slide along the coil. The coil is made up of many turns or tightly wound copper wire. When an electrical current flows through this wire, a strong magnetic field and flux is created. The housing, usually made of iron or steel, is around the coil, concentrating the magnetic field generated by the coil. Okay, the third part is the plunger is attracted to the stop through the concentration of the magnetic field, providing the mechanical force to the work. It moves from its position due to the magnetic attraction, hence connecting two copper terminal of the contactor switch. This will complete the circuit from the battery to the motor, causes the motor to spin. The spinning motion is transferred to the pinion. The pinion turns the flywheel, which in turn drive the crankshaft or provide torque to the crankshaft to function. This will start the combustion cycle and engine will start. Okay, then come to the last part of the step. When the ignition switch is turned off, we cut the power to coil, the solenoid is energized, disconnecting the motor from the battery, then the plunger come back to its original position with the help of the spring that attached to it, and the circle is incomplete. The motor cannot be rotated, hence causing the spinning of the pinion and the flywheel to stop. The cycle combustion is then stopped and the engine stops. So why we have to use solenoid? Why? Okay, let me talk about the advantages of using solenoid. The advantages of using solenoid is it requires a lower current to operate. If not using solenoid, the circuit is the high current demand of the motor. The motor will considerably powerful and demand heavy current for operation. To handle this current, the ignition switch needs to be unusually large. It also requires very thick wire to running from the battery to the switch and then to the motor, which technically inconvenience. We can reduce the inconvenience that might have faced by the owner by using this solenoid. Also, the solenoid helps to slide the pinion and engage it with the flywheel before the motor starts to spin. This helps matching the pinion with the flywheel more conveniently. The different size of the pinion and the flywheel make it able to obtain the higher torque from this gear reduction. So, we can conclude that the mechanism of this starter solenoid are not only depending on the magnetic fields concept but also the concept of torque, since the engine is made of the gears that will then require torque to rotate. So far, this is indeed the best solution in automotive that giving us the advantages to reduce the current use. That's all from me. Thank you.